The last two examples are doing a little bit of investigative work to find out specific parts about a row of Pascal's triangle. You can see here we're dealing with the 12th power and 10th power. We don't want to write all that stuff out, so we want to find some patterns here. So first of all, I want to find the coefficient. In other words, I want to know what the number in front of that term is going to be for the term that contains x to the 8th. Now, I know the first piece here is x squared raised to the 12th, so the first term is going to be x to the 24th. Then I'm going to decrease as I go along, so it's going to be further to the back. So let's think about this in reverse. I've got a bunch of different little blanks right here, and let's say this is the 13th term, because we know there's going to be 13 in the expansion. So the first piece here is x squared. This is going to be x squared raised to the 0. This would be x squared raised to the first, which is just x squared. Then we have x squared squared, x cubed squared, and x squared raised to the 4th. So if I think about this backwards, I know that my final term is going to have the first pieces being raised to the 0. The 12th term will be raised to the 1st. The 11th will be squared, the 10th will be to the cubed, and then the 9th term is going to be to the 8th. And the reason for that is 2x squared raised to the 4th is x to the 8th. That's the 9th term. I could do the exact same thing going forwards as well, it's just that I have to work through 9 terms in order to get there. So that 9th term comes from x squared raised to the 4th is x to the 8th. So I'm dealing with the 9th term. And so what is the 9th term look like? So let's just zoom in. If I were to have this, I'd have the blank right here on every side. And I just want this 9th term. Well, what would it look like? Well, we know right here this is 12. So it's going to be 12 choose something. And since it's the 9th term, it's going to be 12 choose 8. The reason for that is, remember, we start with 0, position 0. So 0 is on the first term, 1 is on the second term, 2 is on the third term, 4 is on the third term, and so forth. So that means 8 is on the 9th term. So it's 1 off from there because we have to include 0 in our counting. So 12 choose 8. We know the next piece is going to be x squared raised to the 4th. And then we know the 2 in the back has to be raised to the 8th. Reason for that is we know the total, if we add these exponents, always has to equal 12 for every single term. So now I want to know the coefficient. 12 choose 8 is 495. X squared raised to the 4th is going to be x to the 8th. And then 2 to the 8th is 256. So 495 times 256 is going to give me my coefficient, which is 126,720 x to the 8th for that term. So I want the 126,720. Finding the 5th term of the expansion, 2x minus 3y raised to the 10th. Just think through this again. 1, 2, 3, 4. Oh, here's my 5th term. It's going to be that one I'm working with. So since I've got something on raised to the 10th, it's the 10th row. So 10 choose what? Well, this is 10 choose 0, 10 choose 1, 10 choose 2, 10 choose 3, 10 choose 4. So my coefficient is going to come partially from 10 choose 4. I know right here I'm going to have a 2x term and I'll have a negative 3y term. Well, this one would be 2x raised to the 10th, 2x raised to the 9th, 2x raised to the 8th, 2x raised to the 7th. So this is 2x raised to the 6th. And I know the total for all the exponents has to be 10. So that means the y piece is going to be raised to the 4th. I can also look at this as being the y piece is 0, y to the 1st, y squared, y third. There's my y to the 4th. 10 choose 4 is 210. 2x to the 6th is 64x to the 6th. And negative 3y to the 4th is 81y to the 4th. So 210 times 64 times 81 is going to be 1,088,640. And then I've got x to the 6th, y to the 4th. So there's my fifth term of the expansion of that binomial.